Yeah. Are you teaching training?
No.
Question, but are you like on with us? We're supposed to learn that algebra too.
You're really great.
That's whoever's fault is out.
I went to that high school.
For Von Wales, was it?
We were for, I offered to go to work for her. I offered to go to work for her. Yeah, I was like,
I would die.
me too. I told her I'd march into battle for her.
She's pretty bad about grading. She's all stressed out. But I want to go talk to her about it. She's like,
What are you guys? Thanks for coming, even though it's close to Thanksgiving. Now there are enough seats for you to come all the way to the front, please. Everyone to the front. Oh no, it's your turn. But the guys on the last row come to the second row. Please. Right here, man. Right there. There you go. Okay, right there. Andrew, you need to come to the second row, man.
but there's no room in the second row.
Well, I have good news and bad news.
You have most of the homework done.
I have all the homeworks.
Oh.
Bad news. Some people did not do homework number 3, so they have 0. Okay. That's good?
What was the score of it?
I don't know. I
Alright.
decided.
Oh crap.
Okay.
And you done that.
Compacted symmetric spaces, sequences, subsequences, and convergence. Convergence theorems. Okay. Who needs extra points in the test? Extra points? All right.
You have to do that.
All right. Who needs extra points again? In the test? All right, Eric. Write the definition of convergence. Xn converges to X. If and only if, go for it. Remember?
Can I have a different definition?
No. The one we did in the general topological spaces.
Can you repeat it?
You can close your notebook. Sarah, can you approve it? Just start. Don't worry, just start.
The definition of what?
Of that. Xn converges to X.
I need.
All right, Sarah.
I forgot
Oh, who else needs points?
Was I going the right way?
Manuel, do you need points?
Yeah.
All right, come in, all right. All right. No, you have your notebook open, so you can have your.
Is it the one with the three?
No, that's a topology.
Oh, I'm there.
What's a neighborhood, by the way? Whoever used the word neighborhood in their homework, Dad, we haven't even seen that concept. So far, so good. No, there are no balls in topology. The balls are in metric spaces, not in topologies.
Well, then, whenever it's more of it, it's still in that, it converges to that point.
All right, let's go try it, man. Give a clap to all the participants. Okay, nice job. It takes some guts to try, right?
Yeah.
Just to be up front. Haley, you have your notebook open. Doesn't count.
It's not on.
All right, Haley, come, show us some power. Pay attention for the other people who like don't even know anything about life. All right, let's see it. you have only 2 mistakes, but that's almost right. Almost right. Almost right. Jorge, you cannot participate because you're already watching. Adam?
Correct mistake.
Okay. Correct mistakes, Adam. You have not sent me your homework number 3, have you?
I have.
You have? Okay. Did you print it out? You need to print it out, okay? Thank you very much. Thank you very much. Good job. Good job. So let me just adjust it a little bit. We don't need this item because we're already saying X and convergence, so X is already kind of given to you in the problem.
Okay.
Or in the definition, right?
Okay.
So we don't need that. So you can just raise the 0 here. All right, who wants to read it in English? Who wants to read it in English? All right, Manuel, go for it.
All open sets, there, with a point, there is a number from the natural numbers such that for all numbers greater than that number from the natural numbers, the point is in the set.
The point xn, the point xn.
The point Sn is in the set.
Right.
Would actually be a sequence now, so like any of those elements, or just one specific one?
Well, this is true for any n. So xn is in G. So if you take a larger n, that also is in G. In other words, all the points after that n0, all the points in the sequence after that n0 are in the open set. So let me write it in English here for any open set containing x. So that's this part. Do you guys agree? Yeah? There is a moment after which, that's after which the sequence is in the open set. So after that moment, the elements of the sequence, not the sequence, the elements of the sequence, because the sequence means all of it, right? The elements of the sequence are, not is, are in the open set. Can you memorize it in English, guys? For any open set containing x, there is a moment after which the elements of the sequence are in the open set.
So there has to be some finite point in which all of them are going to start.
There is a natural number. That's the index, right? That index. After that index, the corresponding element of the sequence is in the open set. Can you memorize that in English, guys? Yes? If I ask you next time, can you say it in English rather than in symbols? Yes? You promise for extra points? For extra points, guys? Okay. So that's a definition in general topological spaces. Now let's say that we are, say that let xn in metric space ED. It is the same definition. I'm just going to apply it from topological spaces into metric spaces. There's an arrow going from topological spaces into metric spaces. So I'm going to go ahead and copy the same definition, but don't write because it's wrong. Okay, I'm going to adjust it. So don't copy. Okay. Don't copy that one, that's wrong, okay? Don't copy that one. So if I'm going to adjust that definition to the metric space case, I'm going to change the open sets by what? I'm going to grab the open sets, say no more open sets. Instead of open sets, I'm going to consider Marlene in a metric space. Instead of open sets, we have balls. Okay, Marlene, balls. Okay, so let's go ahead and change the open set with a ball. Okay, so how can I say it? For any open set that contains X, I want to say it for any what? For any ball. We just disregard the word open because balls by are by definition open. Because the union, the topology is given as union balls. So one ball is a union, so therefore it's open.
And why
So-
do they use the word open ball then? Is that just like?
Yeah, that's just like pleonasm. Is that the word?
Planism?
Yeah, pleonasm, whatever.
They want to really make you unsure you understand what's going on.
Okay, hold on. So let me erase that for any open set that contains X. Instead of that, I want to say for everyone, for all ball. Well, to describe a ball, you need two ingredients. You need the center and the radius. The center is kind of already given to us. Don't you agree? The center is who's going to be the center of the ball? Okay. Let me do the yeah. So who's the center of the ball already? Who is the center of the ball, guys? X is the center of the ball, right? So in reality, if I want to say for any ball that contains X, I really mean for any radius, because the center is already given. You see what I mean? You need two ingredients, center and the ball, but if the center and the radius. But if the center is fixed, the radius is the only variable, the only thing that changes. So instead of saying for any ball, I want to say for any radius, you see? And I'm thinking of the ball of radius R center at X. For any radius, there is a natural number after which Xn is not in G anymore, not in G, please help me guys, participate, okay? Like this is, I heard this psychological phenomena that happens, but there are many people, like no one participates because they say, well, someone else will do it, someone else will take care of it, and if all think like that, nobody takes care of it, you see what I mean? So we need to participate as if you are a single person in this classroom, yes?
Why does R have to be just greater than zero? Should it be greater than equal to? Is
No,
that the case for
no, because the radius equals 0 is a dot. It's a ball that it's only a
Oh,
dot.
because X isn't part of the, is it because X isn't part of it? Because I always thought that like, we had to have dx of X.
No,
equals
X
0.
is the center of the ball.
Right, so we can't have that because I didn't see it.
No, because if you take the ball of radius 0, center at X, that's really one dot. It's really X. So it's like a degenerated ball. So you want a general ball. For any radius greater than 0, so we don't say Xn is in G. Xn is in the and the ball of radius R center at X. That can be true, but don't write it, Ross. Don't write it. It's always adjusted, okay? So saying this, that X is in the ball, is equivalent to say that the distance from Xn to X, J, don't write it. This is wrong. Don't write it. So if you say X is in this ball, it's equivalent to say the distance from Xn to X is exactly what we're going to change that. So the distance from Xn to X is less than the radius. So that's the definition. All right, now you can go ahead and copy. You see how it changes slightly with some? Now you can copy now, sir. Now which one is easier, guys? That one, right?
Yeah.
Metric space is easier, right?
Because
Okay,
this
and
is more,
it
this
is
is more general, right?
yeah, this is more general.
Okay.
So we say here, we say that xn converges to x if and only if that happens. So that's a convergent definition in metric spaces. Ready, guys? Should be faster than copying and faster. Boom! You need to copy faster. That's a student skill, okay, guys? Raise your hand if you finish copying. Awesome, awesome. All right, now I'm going to move from metric spaces into a specific metric space, and that's called into the real numbers. Let xn in R. In R, you know this metric space is the real numbers with the absolute value distance. The distance is the absolute, the distance between two numbers is the absolute value of x minus y, right? The distance from x, y is the absolute value from x, y. So let xn in the real numbers, all right? Or you can say like this, let xn be a sequence of real numbers in R with the usual distance, usual metric or metric. We say that xn converges to x if and only if. We don't need to define it. We can just say, well, it's just general. We already have it. Why do I need a new one? We want to particularize the definition. Ready? 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 Okay, here we go. So I'm going to go ahead and copy. Don't copy that, Jay. Sarah? Because this is wrong. Okay, I'm going to adjust it. For every, instead of R, I can call it epsilon if you wish. Or R, it doesn't matter. This letter doesn't matter. I'm going to call it epsilon. For every epsilon greater than 0, there is an n0, a natural number, such that after that, the x and x is less than epsilon. Do you agree that this is the same definition as that one?
No, Professor, that's epsilon, the other one is R.
It's the same thing, right? It's just the same. Alright? Alright, so in the real numbers, I need to, this doesn't change, this is the same, this is the same, this is the same, there's nothing specific about the real numbers for these numbers. But this distance becomes what? This distance becomes the distance from xn to y in the real numbers with the absolute value. This distance becomes everyone I want to participate, everyone I want to consider.
Yeah, I see.
Guys are my favorite students. Those guys are like, what? Like what? No, you have to participate. The absolute value of xn minus s. That's the distance in the real numbers. Remember, guys?
Well,
Yeah.
why would we have to rewrite it? It just means the same thing. If you follow it.
That's exactly what I said before. We don't need a new definition. We're just going to particularize. Because for some people, it's hard to abstract things like this. For some people, this is more intuitive. Okay? And so sometimes in this class, we need to pay some price, Chase. The price is intuition versus abstractness. How do you say abstractness? So, all right. So this is more intuitive for people. Some people say, this is so out of the world for me, but this I can get. So once they dominate this, they can jump from here to here and then from here to that or something. You see what I mean, guys? All right. So that's the definition, and based on this definition, I'm going to go ahead and prove the following: that x equals the real numbers, d equals the absolute value. Prove that this is the first sequence, that the sequence 1 over n converges to 1 over n converges to, oh shoot, I forgot the limit. Okay, Robert. 1 over n converges to 7?
No.
What does it converge? 1? Let me see. 1 over 3, 1 over 4, 1 over, oh, those are getting small. I don't think it's getting close to 1 over 0, exactly. 0. Nice. 0. So, proof. Should I start like this? Should I start like this? Or should I start like this? The old one, because this is a real number situation, right? So you say, let David and Eric, can you see it?
Yeah.
Let epsilon be a positive number, right? So far so good, guys? So that means I have achieved this part, okay? I'm going to put a check there because I took care of that, right? What am I looking? What am I looking? What's my goal, guys? My goal is to find, right? To find a natural number, right? That's my goal, to find a natural number n0, such that this happens, all that happens. Do you guys agree that that's my goal? Yeah? That's my goal. All right, here we go. Look, 1 over epsilon is a real number. Do you guys agree? Yes? By the, raise your hand if you know the answer. What I'm going to say, there are 2 words. By the, all the way up, all the way up. Okay, some people don't say it. That's because they haven't done the homework number 1, where you have to do things that are super small. Some people are trying to use convergence, but there is no such thing. By the AP, which means, give me a property. There exists a, oh, there we go. There we go. Beg your pardon? No, I want to stop a little bit here. So, because I have a point to make. Your goal is to find a natural number. In all the proofs about sequences, each time if your goal is to find a natural number, pretend that you are in the jungle with a rifle and you're trying to kill a deer, which is actually a bad thing, or hunt a deer. How about you want to kill a mosquito that has been bothering you forever, okay? You want to kill a mosquito, right? How about a skunk?
We should get to a gazelle because you said jungle, and I don't think deer live in jungle.
Okay. How about let's pretend, no, wait. Let's pretend we're looking for a skunk. So an animal that is black and white and smells terribly, okay? So you are walking there, right, with your rifle, and suddenly you see something over there that is like kind of black and white and smells so bad. At this point, you don't go like, whatever. You don't go like that. You say, oh my goodness, I think I was looking for it. I think I got it, right? Don't go like, oh, that may be like a dog or something. No, don't go like that. If you're looking for something and you spot something that has the characteristics, it has to be a skunk. You see what I mean, guys? Maybe it's not the skunk that you were looking for, but at least it's a skunk, right? So next time in the future, when you're looking for a natural number, and suddenly, somewhere, you arrive at the point, oh, there exists a natural number, that's when your smile should go big and say, oh, I was looking for a natural number, I found one, I think I'm happy. Because some people, after they find the natural number, they forgot that they were looking for a natural number. And so they still cannot connect the pieces. They were looking for one, they saw one, and they still cannot connect the pieces together. You see what I mean, guys? When you're looking for a natural number, you found one, you have to say, I think I got it. You have to say, I think I got it. Alright? Don't go like, whatever. No, you have to smile, you have to be happy about it. I think you found. Alright, so I found a natural number, and I need to check this, but first let me continue. Joseph was right. Should we continue here? There's a natural number such that what, guys? Such that n0 is greater than 1 over epsilon, right? Yes? Alright, I think I found one. So I'm going to put a check here because I found it. Now, all I need to check is this piece right here. All I need to check is this piece. Well, if I want to check that for any n greater than or equal to n0, this happens, I'm going to start by this point is that we're in the last part of the semester reanalysis, and you should be able to say it. I need to check that for any n greater than or equal than n0, this happens. If I want to check that, I need to start by, you have to say it. You have to learn it. We're so far in the semester, you say, I don't know, what? You should be able to do it. You are grown-ups already, right? I should start by taking. Gosh, just for all, just take one, come on. If you don't know it, then you are so lost in the semester, right? So you say, take an n greater than or equal to 0. Got it, put a check on that. I'm only shooting for this, do you guys agree? I'm only shooting for this inequality. If I get that inequality, I'm done. Getting that inequality, I'm done. So I'm going to go ahead and do it. So xn minus x, in this case, is the absolute value of who the heck is xn in my problem? Who the heck is xn in my problem? You don't know it? It's 1, right? 1 over n. Minus, who the heck is x in my problem? Who the heck is x in my problem? 0, right? Which is 1 over absolute value of 1 over n. What's the absolute value of 1 over n?
1 over n.
1 over n. So far so good, guys? But look, n is greater than n0. I need something else. N is greater than n0. So then, if n is greater than n0, and n0 is greater than 1 over epsilon, what can I conclude? N is greater than n0, and n0 is greater than 1 over epsilon, what can I conclude? N is
Less than 1 over epsilon.
no
Greater than or equal to
greater,
1 over
not
epsilon.
less. Greater. Are you confused the greater with the less than? You're not confused because this is kind of tiny, this is a huge one.
Oh, so you're going to say 1 over n is less than epsilon.
Okay.
Because you can flip it.
So then you flip it over, so you conclude that 1 over n is less than epsilon. And period, we got it. The absolute value of that is less than epsilon. So I'm going to go ahead and frame what we need. We took an arbitrary epsilon, right? And we found a natural number. What is the peculiarity, or what is the characteristic, or what is the virtue of that natural number? The virtue is that if you take a number n greater than n0, this distance is less than epsilon. If you put all those boxes together, what does it say? Because since epsilon was arbitrary, I can conclude, therefore, then I'm going to write it here. Then, since this epsilon was arbitrary, I'm going to put all the boxes together and say, for all epsilon positive, that's this box, then this box, there exists an n0, take the other box, such that for any n, because this n was arbitrary, this distance is less than epsilon. Therefore, this all is a definition. It's just a definition. Then what can we conclude? All this thing is the same as xn converges to x, right? That's what we want. Where xn is 1 over n, and x is 0, right?
So when we do problems similar to this, we have to magically find the 1 over epsilon thing that you did, like for each problem. Because you kind of picked that, right?
Yeah,
Out of
because-
intuition, right?
No, because an angel came and told me.
Okay, angels sing.
Yes, exactly. The only way that you can call angels to your side to tell you things is by doing many problems. Otherwise, angels are not going to like you. They will never show up. Even if you are in desperate need of them, don't worry. You need to do problems. Okay, guys? All right. So that's one example. That's the most famous example. It's the easiest example of all, and that's going to be in the quiz. Can I ask you that in the quiz, guys?
Yeah.
Okay, good. Start with an epsilon. Find this. By the Euclidean property, there's a natural number, you found it. Such that this is true, they can end greater than 0, therefore this is true, and so on and so forth. You can add an extra line here, say, hence,
And it's less than
and
or one over is less than
epsilon is greater than 1 over n. Like, you just move this and this and this and that. Take in advantage that. Taking into account that epsilon is greater than 0, that's the reason why you multiply by epsilon inequality doesn't change. Right? It stays the same because you're multiplying by a positive number. Alright, here we go. Consider R with the topology sorting by topology. Then 1 over n converges to 0. Let me prove it. So am I going to use definition number 1, definition number 2 metric spaces, or definition number 3 in the real numbers? Which one? Topological spaces, metric spaces, or real numbers with the usual metric? Topological spaces, right? This is not a metric space. It is not defined by a metric. This topology is not generated by any metric. That's a hard proof. Okay. I want to believe it for a second. So you say take proof. Take G, an open set that contains 0. How are the open sets in this topology? Open sets are unions of A comma B's, right? Remember? Sorry, unions of A comma B, I want to call it alpha, alpha, alpha. So if 0 is in this union, 0 is in one of them, then